Hi, I'm Kurt Onthing. I'm really sorry I couldn't be there with you today. But what I'm going to do is I'm going to take you through a quick build of some quick and easy lab equipment with open source hardware that you could do in your own lab to kind of give you a crash course into how this works. What we're going to be building today is this. This is an Arduino based hot water bath. And you might notice at the moment it looks like a mess. Really, there's two different kinds of builds that I do in my lab. Ones that are like this that are very temporary. I throw them together for a specific purpose for a short amount of time and leave them kind of messy like this, use them for that purpose, but then at the end of the day or at the end of the project, tear them back down, put the parts away. There's other things like this that I build that are meant to be more permanent. This is also an Arduino-based control system. This is meant to control ocean acidification parameters in an aquarium. And ones like this, I intend to be permanent. I generally 3D print a housing, something else like that to make it a little bit more durable. So let's get to it. How in the world do you put together a quick and easy hot water bath like this? Okay, here is everything taken apart and disassembled in just its parts. So we can go through the different things that you'll need to do this. Now, the first thing, the main part of the water bath is just a rice cooker. This is just a rice cooker I got from Goodwill. I actually get a lot of lab supplies from Goodwill. It was $6.99. Another thing that we're going to use is a control relay. I really like this one that you can find on Amazon. And what this does is it allows you to use the 5-volt logic from the Arduino to turn on and off high voltage power supplies. So like the rice cooker here. The brains of it is going to be this. This is an Arduino Nano. I really like to use these for these kind of temporary projects because I can just plug them right into a breadboard and begin wiring them in. Which brings us to a breadboard. We're going to need a small breadboard like this. We need some things to plug in the Arduino. So what I have here is a USB mini cable and then just a wall wart that we can plug this into to get power to the Arduino. We'll also need this to code that. We have this. This is a Max 31865 breakout board from Adafruit. This is a 1602 LCD screen. We're going to use this to see what the current temperature in the water bath is and to see what the set point is. The ones that I'm using here have this backpack on them. It's an IC squared backpack that's going to allow us to use only 4 pins to control this and write to that. In addition to that, we have a PT100 temperature probe that we're using. This one is kind of old and rusted, is what I happen to have at the moment, so forgive that. Normally, I like to use ones that are longer in the ThermoWell side here that would come out quite a bit longer and aren't rusted. But this will get us through for today. And then also, you're going to need some jumper cables. Here I have 8 jumper cables that are male to male, and I have 4 jumper cables that are male on one side and female on the other side. One of the things that I should talk about here first is how breadboards work. Now, a breadboard is this board with a lot of small holes in it. It allows you to prototype and put together electrical components and wire them to other electrical components really easy and really quickly using just these jumper cables here. And so if you look at this here, let's take a look. You have 2 major kind of sections here. This middle section that has several rows and columns of holes here, and then we have these 2 outer sections. These 2 outer sections that have 2 columns each are what are known as the power rails, and you can hook up power to those, and those, each column is connected electrically all the way down. So if I were to plug in, for instance, wire here and a wire here, those are now connected. In addition, in this central portion, they're electrically connected in rows, so in this direction. So if I were to plug in a wire here and a wire here, those ones are now electrically connected to each other. Okay, so with that basic out of the way, let's talk about actually putting this together. First, we are going to take the Arduino Nano and we are going to place it on the breadboard, and we're going to place that so that is straddling this central groove right here so that we have one set of these pins on either side of that. So I'll just take that and put that down there. Next up, I'm going to take the Adafruit Max 31865. This allows the Arduino to communicate and read the temperature from this temperature probe here, the PT100. So I'm just going to place this in here. Now, how I'm going to place it is I'm going to place it so it's facing outwards here with these pins all going along in a single column on different rows of this breadboard here. The next thing I'm going to do is I'm actually going to attach or wire this breakout board, the Adafruit Max 31865 breakout board, to the Arduino. I'm going to do that by placing jumpers between the rows here that connect them. So the first jumper I'm going to take is I'm going to place in this row with the column that says CS on it. I'm going to place that over here on the one on the Arduino that is D10, and D10 is right there. Next, I'm going to take another one. I'm going to use a different color here, and I'm going to put it right next to this where it says SDI, and I'm going to then wire that to the one here on the Arduino now that says D11, the SDO to D12, the CLK to D13, which is on the other side right here. Ground, GND pin to ground on the Arduino. There's actually several of them on here. And VIN on the Adafruit to 5 volt on the Arduino. So 5 volt is right, where is that? This 5V pin right here. Okay. Next up, I am going to attach this PT100 temperature probe to the Max 31865 Adafruit breakout board so that it can read the temperature off this. Just attach one, screw it in, attach the next one, and screw it down, attach the last one, and screw that one down. Next up, I'm going to attach the 1602 LCD screen. So I'm going to use these 4 male to female jumper cables. I'm just going to take those and on the back here, connect them. Oftentimes the female ends here are having a block, and I can hold them together and just insert them all together. Okay, now if we look, we have this blue one is going to ground into the ground pin, where I also place the ground pin from the Adafruit. It can be in that same row. I'm going to place this green one that comes from VCC here into the 5 volt SDA into the A4 pin, SCL to A5. Okay, now this is all connected here. The next thing I need to do is now connect all of this to this relay controller. So if you look along the side right here, what we have is we have this little terminal block that we can actually pull out. I'm going to take this orange one, I'm going to put it into this side, which was the plus side. I'm going to put it into the minus side. I'm going to place that now back into the block on the, or the receptacle for that on the relay. And now this white one can go to ground. And then now this other one, this orange one that goes to positive, this one is now going to go into D8. That's the one in the code I am going to designate as being the one that is going to send the signal to this relay. Next up, we need to add code to the Arduino that's actually going to tell it how to run this entire system. So how we're going to do that is we're going to take this USB mini cable. We're going to plug this side into here, into the Arduino Nano on this side. And then I'm going to plug the other side into my computer, which by the magic of editing, I have here right now. And now I just hook the other side of this into a USB port here into my computer, and I can begin coding. Okay, now we're here in the Arduino IDE. This is a program that you can download from the Arduino website for free that allows you to write code and upload code to Arduinos and other compatible microcontrollers. I'm not going to go through all of the code other than to say it's really short here. It's only 54 lines of code. That's including all the spaces and comments I have in here. I will make this available for you to download and so that you can replicate this. There are a couple things that you do need to know. First off, you do need to have the libraries installed. These first two on lines 1 and 2. Copy the library name, the Adafruit Max 31865 library. So I'm going to highlight, Control-C, go to Tools, go to Manage Libraries. Then I would paste that name into this area up here. And when the library comes up, you just click on Install here, and it'll install that library. Do this both for the Adafruit and the Liquid Crystal, and you should be ready to go. The other thing to notice here is here on line 14 is where I set the set temperature of the water bath itself. We do that to keep the hardware a little bit simpler. Next, we need to make sure that we are set to the correct Arduino by going to Tools, coming down to Board, and then in Arduino AVR board, select Arduino Nano. Then we need to make sure we also have the right processor. For me, that means the old bootloader here. However, that being said, if whatever you choose doesn't work, just choose a different one. And then on port, you just select the correct port. On mine, it's the only one that comes up. And once you have all of that done, you can click on this little arrow to upload this code to the Arduino. And then it'll say done uploading when it's all done. Now that we have the Arduino coded and all the code loaded up onto it, we can go ahead and put together all of the components for kind of the final assembly. The first thing that I'm going to do is take the cap off of this, and I have some water here already in the water bath. I need to put the temperature probe down in there. I'm going to use this ring stand with this clip-on to do that. So I'm going to take the temperature probe here. I'm going to lower it down to the water because I don't want it touching any of the hot sides. Next up, I'm going to take this and plug in this relay module to this outlet here. Now I can plug in the Arduino here. So on this relay module, we do have this one outlet that says always on it. I am going to plug in the Arduino to that. So I plug in the wall wart and then just the USB into that. We should see this fire up. Finally, we're going to plug the rice cooker into one of these two that says normally off. Now the normally off ones are going to be off unless the Arduino is giving the signal to turn it on, and you'll be able to tell the switch is active based on this switch active light right here. Okay, finally what I need to do is just make sure that this is switched to the cooking mode, and it should be heating now, and it'll continue to heat up until it's come up to temperature. So there you go. In my experience, this setup is able to hold temperature to about 0.5 degrees Celsius. Thank you for hanging in there with me, and here's a simple way that you can get a hot water bath quickly and easily using Arduino.